Yes, today we are seeing about Bjerrum theory of ion association in electrolyte solution. Before starting the Bjerrum theory of ion association, we should know the what is Debye-Huckel theory in strong interactions of the electrolytes or solutions. In Debye-Huckel theory, he doesn't consider the possibility of negative ions which will be surrounding through the positive ions as a cloud, which will not have any free movement, any free place to surround the solution, so that the thermal sorry so that the thermal translation energy would not be sufficient for them to continue the independent movements in the solution. So after that, Danish physicist N. Bjerrum, he discovered a theory known as the Bjerrum theory of ion association in electrolyte. He introduced a ion pair. He said in a solution there will be a positive and negative charges. When there is a reaction takes place, the positive and negative ions will combine and form an ion pair due to the Coulombic force, and some ion will form an ion dipole which will leads to a net charge as a 0. Positive and negative will form as 0, and some ion pair will be stuck as it is in the solutions. So let us consider a spherical shell which has a thickness of dr, radius of r, which has a reference electrode as a positive electrode as z plus e naught, which is in the center as a nucleus in a solution. Let us consider a probability of the radius of the spherical shell. Then we will have 4 pi r square dr, that is 4 pi r square, as you all know that the formula for the spherical or sphere, and n minus divided by v. N is the concentration of negative ions which is present in the solution divided by v. V is the volume of the solution, so we are considering n minus by v as small n minus, and with the exponential of minus u divided by kt. This minus u divided by kt is a Boltzmann constant, and this minus u referred to as minus z minus is a negative charge of an ion, z plus is a positive charge of an ion, e square is an electron, and er and r. Er is a permittivity of the medium, r is the radius of the spherical shell. Then we know that what is n by v, what is u, so we can substitute these two in this equation, and we will get probability of r into dr, which is 4 pi n minus into r square exponential of in the place of minus u we are substituting the value of u, so we will get z minus z plus e square by epsilon or into r into kt. K and t, k is a Boltzmann constant, as you know, kb into dr. Let us consider z minus z plus er divided by epsilon or into kt as lambda. Then we will get the equation as p, probability of radius into dr, equal to 4 pi n minus r square exponential lambda by r into dr. We can write e exponential as exp also. So the next equation as a modified or rearranged equation as probability of r into dr, which will give 4 pi n minus exponential lambda by r into r square into dr. When we see this in a graph or in a solution, if we consider when the probability of radius in the spherical sphere increases, the radius of this spherical sphere also increases due to the volume of the spherical shell. when we consider probability of R is increases, it will increase with radius of that spherical sphere due to that volume. So due to this 4 pi r square dr will also increase as r square. We will get r as a critical value when we plot a graph like this. The graph will be like this, that is probability of radius versus radius of the solution inside an electrolyte. Then if we plot a graph in the positions which we are getting at a critical point, we should know which is a critical point. So we are plotting a graph which is will be like this. The y-axis will be as theta and the x-axis will be as same as r only. Then we know that the closest part of the electrode and the critical point, or which will be in shadowed thing, and I am taking that the closest part of the electrode is r equal to a and the critical point of r is equal to q, and I am considering that r equal to q and r equal to a as a limitations for this as an integral, and we will get this equation if let us consider that q, the charge equal to z minus z plus e square divided by epsilon r into r kt, that you know what is what, and this term is already known as lambda. For q, the lambda will become as lambda by 2 and the equation of this theta will become as like this. Only the difference is lambda by r is turned as lambda by 2r. And next we'll see the Bjerrum expression for ion association constant, which is denoted as Ka. Let us take M plus as a positive ion and A minus is a negative ion, which is combined to form an ion pair as Ma. Let us see how the ion pair will be formed. What is the possibility for that? What it won't possible for the formation of ion pair. If let us consider A and Q. Already I showed in graph which is A and which is Q. If A is greater than or less than, what is what? Let us see that if A is lesser than Q, then that is the possible formation for ion pair. It is the formation will be a possible for the formation of an ion pair. If A is greater than Q, the formation of ion pair is not possible because Q is a charge. Charge should not be less than A, right? If Q is smaller, then how it will form an ion pair? If Q is larger than the A, it will form an ion pair like this, plus and minus as an ion pair, right? So we are considering a ion association constant for this equation as this AIP divided by AM plus into A minus. The small a is denoted as the activities of the species. How the species are activities. What is the activities of the species which is inside the solution for the formation of ion pair. And let us consider in this solution we have three types, that is theta c and 1 minus theta c. Theta is the fraction of ions in the ion pair. Theta c is the concentration of the ion pair which is formed due to the Coulombic force. 1 minus theta c is the concentration of free ions which is not formed as an ion pair. Let us consider or derive this equation as this according to the concentration of the ion pairs, and Ka will become as theta c into gamma Ip, means ion pair. Gamma is the activity coefficient. What is the activity of that ion pair? Then 1 minus theta c gamma plus 1 minus theta c gamma minus. Gamma plus is the positive, gamma minus the negative ion, and gamma is the activity coefficients. 1 minus theta c is the concentration of free ions. We can separate this equation as theta by 1 minus theta whole square, and c by c will be cancelled. We will get 1 by c and delta 1 by delta Ip by delta plus and gamma plus and gamma minus. Ka will be become as theta by 1 minus theta whole square 1 by c gamma ip divided by gamma plus and gamma minus we can write as gamma square in the presence of positive and negative ions. So we are writing as gamma square plus or minus. And this equation, if we consider at very dilution, too much dilution if happens in that solution, we will get Ka is approximately equal to theta by c and the other terms will be cancelled. So we will get Ka is approximately theta by c, and we know that already we wrote this equation theta equal to in the limit of aq into 4 pi n minus exponential lambda by 2r into r square into dr. As we know this equation, let us integrate. After integration we will get theta equal to 4 pi n minus, this value will come out as cube of 3, and after the integral we will get in the limitation of 2 to b e power y power minus 4 into dy. How this term comes? Anybody knows how this term comes? From before, like if we consider b equal to lambda by a, what is lambda? Z minus z plus e square by epsilon or kt, and a here we considering as a as like that as an activity coefficient, as you all know, and it is equal to q by a. How? What is q? Z minus z plus epsilon e square by 2 epsilon or kt. If this divided by 2 comes after this equal to, we will get 2q equal to z minus z plus e square by epsilon r into or kt, then we will get 2q by a. After this, how this y derivative comes? Like this, y equal to lambda by r. If we consider what is lambda, otherwise what is lambda by r? Lambda by r, if we know that q equal to lambda by 2r. If we want lambda by r, the 2 will go that side, then 2q equal to lambda by r. We will get y equal to 2q by r. We are substituting everything in this equation. At last we are getting this equation after the integral. And we are considering an equation for ion association constant Ka in the presence of concentration C. Then we will get the same equation as this. So if we consider n minus equal to Cna by 1000, if we substitute this n minus value in this above equation, the concentration and concentration will get cancelled, and we will get the remaining thing 4 pi Na by 1000 z minus z plus e square by epsilon or kt in the whole cube, and integral of in the limitation of 2 to b e power y power minus 4 into dy. This is the last equation which we derived, right? In this, all this Bjerrum theory of ion association in electrolyte solution, Bjerrum expression for ion association constant, at last what we will get through this? We will get that if the Ka value is increased, the higher the value of Ka, the more extensive formation of ion pair. If the value of Ka is higher, the ion pair formation will be more. If the value of Ka is lesser, the ion pair formation does not happen only, right? So at last we comes to know that due to the Bjerrum theory of ion association, that Ka value increase, the ion pair formation will also increase. Thank you for this watching video, and do subscribe and like the video, and do comment if you want any new videos according in this or in whole chemistry. And thank you. Do subscribe. Bye.